we have three standards, the EN 10143, the EN 10346, and the EN 10169 plus Amendment R1. The EN 10143 concerns the tolerances and the metal core. The EN 10346 concerns the protection against the corrosion made with metallic coating. The EN 10169 plus Amendment A1 concerns the protection against the corrosion carried out with organic coating. So these three standards concern the raw material. After, we have a CE marking of a product, and we have a CPR, the Construction Product Regulation. It's a regulation, so it's obligatory, mandatory in each country. We have two families, for non-structural products and for structural products. For non-structural products, we have two standards, the self-supporting standard, EN 14782, and the fully supported standard, EN 14783. How to use these standards? If the span of a profile is inferior to 400 mm, you have to apply the fully supported standard, the EN 14783. If the span is above 400 mm, you have to apply the self-supporting standard, the EN 14782. These products are in class 3 for non-structural use. That means that the product transmits only the load on its support. The EN 508-1 is useful to determine the measurement and the protection phase. For structural product, we have to apply the EN 1090-1. We have two categories, class 1 for the diaphragm use and class 2 for the collaboration between the member and sheeting. The diaphragm, you have this system when you use the cold form element to stabilize the construction against the wind and against the earthquake. The class 2, it is used when the profile collaborates with the members. Okay, it's the CE marking. Now the design and the erection of a system and buildings. You have the design test and calculation, and for that you have to apply the Eurocode. You have three parts of the Eurocode, part 1.3, part 1.5, and part 1.8. Part 1.3, its corrigendum and its national annex concern the general design. Part 1.5 plus its corrigendum and national annex concern the effective width. The part 1.8 concerns the assemblies. So three parts of the Eurocode EN 1993. For the building erection, you have to apply the EN 1090-4 for the steel products. Okay, now we are going to study the profile steel sheeting covered by the GRISPE Plus project. The first family is the decking with embossment and or indentation and the decking with outside stiffeners. Indeed, this profile are covered by the Eurocode, but you can only design this profile by testing today. You have no method to calculate this profile. That is why, during the GRISPE project, different methods were proposed to calculate this profile. How to take into account, in fact, the embossment and the indentation in the calculation. The same thing was done for the decking with outside stiffener. And here you can see a diagram of stress that explains which stress must be taken into account. So, the first part of GRISPE, how to calculate, how to take into account the embossment and indentations. Another topic of GRISPE was the liner trace, and especially the distance S1. You remember, some slide before, I explained you that due to the thermal regulation, we add spacers between the liner tray and the outside skin. This spacer, the distance between these consecutive spacers can be 1 meter, but can be 2 meter, 3 meter, 4 meter, to avoid thermal bridge. But when you do this, you have a local instability of the flange of a liner tray. That is why it is necessary to take into account this in the calculation. It is not defined in the Eurocode today. It was developed in the Eurocode in the future, thanks to the work of GRISPE. Another topic concerns the corrugated profiles. You have here some examples of corrugated profiles. Again, no methods exist in the Eurocode to calculate in bending these profiles. Two methods were proposed in the European project GRISPE to calculate. One is forfeiture, another is calibrated in detail. Another topic concerns the curved profile, and you have two families again. You have the curved profile. When you put this profile on the work site, the profile takes naturally the shape of the structure. It's the first categories of calculation of profile that don't exist in the Eurocode. Another solution, you pre-curve the profile in manufacture, and this profile is transported like that and put on the work site like that. And in function of the support, you can have a horizontal support or block support, you can have an arch effect or no arch effect, and no calculation method exists in the Eurocode. For these two categories, a new system, a new approach was defined and will be in the future in the Eurocode. Now the assemblies. You know, sometimes for the work site, we need to have profile of 20 meters, for example. Of course, it becomes difficult to transport this type of profile of 20 meters. For that, the profiles are cut in two parts of 10 meters, for example, and reassembled on the work site. But to do this, you have to calculate this assembly, and it is not defined in the Eurocode. That is why, in the GRISPE project, 4 types of assembly was studied. In the first, the cantilever above profile, you can see that the profile on the left is above the profile on the right. For the cantilever underneath, you can see that the profile on the left is under the profile on the right. We have another type, the overlapping joints. In this case, the overlapping is symmetric. You can see a vertical axis in front of the central support. And finally, we have a continuous profile with the local reinforcements. So a piece of metal is added to reinforce the structure and the sheeting on the support. So 4 types of profile, 4 types of assemblies. To do that, 4 tests were done. The first test was done on continuous profile, that serves of reference, and 3 other tests were done about the DIN overlapping, about a 2-slided overlapping, and the continuous profile with reinforcement to obtain data to calibrate the design method. Another topic concerns the acoustic. Due to acoustic, it is interesting to create perforation inside the cold form profile. This perforation can be on a triangular shape or a square shape. The problem is that on the Eurocode cover today only the triangular shape and not the square shape. That is why this new distribution of the perforation was studied in the European project GRISPE+. Another topic concerns the services. Some tubes can go through the profiles and create hole, circular hole or square hole. Again, no method, no design calculation will exist in the Eurocode, and it was developed in the European project GRISPE. The last concerns the plank profiles. These profiles are requested by architects that want to have facade without visible fasteners. You can see here 2 types of clip joint and chevron-shaped joint that allow to hide the fastener. The problem is when you do this, you have a specific value that is named is dislocation that don't exist in the Eurocode. That is why a new method was proposed to calculate this assembly in the Eurocode and to calculate also the plank profiles.